Today I'm going to talk about Gradio and how you can create demos for your machine learning models or any other model that you have with Gradio rapidly. So, what is Gradio? Gradio is an open source Python library that allows you to quickly create customizable web interface for your models. For example, you have your code and you want to share the result in a more visual or intuitive way with others. So what can you do with Gradio is you have your Python code, you have to just add some simple codes, Gradio codes in it, and then you can just open your web browser and here is your UI. So Gradio is created in 2019 and it is now part of a Hugging Face ecosystem. It has been downloaded more than 3 million times and been on GitHub for a long time. With working with Gradio, no front-end experience needed at all. It can support multimedia inputs like text, images, audios, and videos. And it is ideal for prototyping and demos. Okay. What are the key features of Gradio? So, as I mentioned, it is great for rapid prototyping. You can create your UIs for machine learning model with just a few lines of code and also enabling a shareable demos in a minute. You can generate temporary public or embed interface in notebook, website, and Hugging Face spaces so that you can share it with other researchers or any other persons you want. It utilizes more than 40 built-in components for text, images, audios, videos, and more. And also it can easily be extendable. Here is the website for the Gradio. It has a complete and full instruction on the features of Gradio and how you can use it to build your demo and UIs with many examples there. So I recommend you to look at it and see what Gradio can do for you. So let's get started with Gradio. As I mentioned, Gradio is a Python library. So like any other Python libraries, what we have to do is first create our virtual environment. Then we have to install the Gradio. You can use the Gradio on your local computers and Google Colab or also on the clusters that we have. For using on your local computer, just simply pip install Gradio in your environment. And on our cluster, it has been supported on the build. So what you have to do is just pip install --noindex Gradio, and then you'll have it. But for working on the clusters, there are some additional steps that you have to follow to do the port forwarding. So first of all, on the last line of your Python code, we have this demo.launch command here, and we have to put this additional settings for it, the server names and the server ports, so that we know where should we look at it when we are opening our browsers. On your local computers, use this command, substitute with your username and the clusters that you're using. And when your job ran on your compute node, just substitute the node with the compute node that your job is running on and your username. And then you're good to go. You can just open your web browsers and go to the specific server name and ports. And here is your UI. So the simplest Gradio is really simple. It may just take 7 lines of code to create a fully functionable web interface for you. It has so many features, but the most simple one is interface. So how we can work with it is I'm just importing Gradio like any other library. This is a really simple function. It's a grid function that have name and intensity as input. And return hello plus the name plus exclamation multiplied by the intensity that I defined here. And for creating the UI, I create a demo and calling the interface class, giving it what function I want it to run, the inputs and the output. So the name will be a text box. The intensity, I define it as a slider, like you can see in this picture. It can be number if you want it. And the output is also the text. And then at the last line, I have this demo launch. So to run it, I have this my code in VS Code. I'm gonna run it, and it tells me that it's run on port 7861. So let me just go to that one. And here is my demo. So I'm just gonna give it my name, defining the intensity, submit it, and here is my code. I can clear it as well. I don't want this input and type it again. So it is really easy to work with. Okay. So based on your code and what you want to be shown and shared to others, you can have defined inputs or outputs in the interface. For example, in the codes that I've shown you, we have inputs and also outputs defined. So this is like this one. But sometimes, for example, if you're using some kind of GAN model that you don't need any inputs, you can just use the interface and put the input as none and only shows the output here. Or when you just want to collect data and no outputs is needed, just put the outputs none. And in some cases, for example, when you're generating text, you want, you say you have a text box, you put a prompt in it and ask it to continue this prompt for you. And you don't want to create another box for the output. You want everything to be at the same box. So the outputs will be the same as the inputs. Based on your need, you can just work with it and play with it to get the UI you needed in the interface. Another feature for the Gradio is blocks. It gives us more power to design a UI the way that we wanted. So these components that I'm talking about and the way that is defined are for the blocks that I will talk about in the next slide. But we saw some of those. For example, we have text box and a slider in the interface. So for to define it, we have to use gr text box in the block features. You can give it a name, a label for every components you have. I also defined a placeholder and a line to show how many lines my text will be. Will it a single or a multi-line text? For the slider, you can have a minimum and maximum amount specified and also giving it a default value and step here. The number is just giving it a value if you want to, default value, and also you can define the precision for that number. The radio is a button group to select one option from a list. So I have to give choices here, and the rest is like before. We have images. You can just create it with gr.image, giving it the type of the image you want and also the shape. We have checkbox. It's a single checkbox that's used for binary true or false input, but we can also have use checkbox group that I use in another code that the user has the ability to check more than one options if it's your case. You can also create a data frame, giving it the header, the number of the row, columns, and it will create you the data frame you want. Also the drop down menu, giving the choice like before, and also the plot. So you can show your display your matplotlib or plotlib figures on the Gradio with the gr.plot. Also, some charts are supported on Gradio, like the bar plots. So you can just call the bar plot and it will just create your plots for you. There are additional components like audio, videos, and files also supported on Gradio, which I didn't bring here, but you can just upload your audio or images from your local computer or from the webcams that you have and microphones. So let's look at the Gradio blocks, how it will look like. So the Gradio here, this is a simple calculation. I have two numbers, the operation for add, subtract, multiply, and the results. And also I have some examples provided for this calculator. So the code will be like this. So this, first of all, importing Gradio. This is a simple function that I have for each operation to return the value for me. But as we know, we cannot divide a number by 0. So if this happens, I can raise an error in Gradio with gr.error and just mention that cannot divide by 0. It will give you a red box and saying this prompts in it. So will be useful sometimes if you want to tell an error to the users. You can do that by this way. Then you have to use it with gr.blocks. You can create a block, giving it a title, markdown if you want. And in Gradio, if you don't, every component that you specify will be stacked together in columns. So if you want some of them to be in one row or in many more than one columns, you have to define it with gr.row or gr.columns. So here I have my two numbers defined with gr.number. I have operation with gr.radio, giving it the choices, and also my output is a number. I create a button, the calculate button here, and mentioning that if this button is clicked, you can have many trigger for your button that you specify. Here I'm using the click. Run this function, this calculation function, giving the input and also the output. Sometimes you want for your code to have some examples for users to work around. So here with GR examples, you can do that, giving the examples you want, the numbers and the operation. And at the end, you have to specify the inputs so that the Gradio knows which one is which one is a number and which one is the operation. And at the end, launch your demo here. So if I run this code, so here it is. So I'm just using simple. I add those, I can multiply those, or I can use these examples that I defined. So, and if I divide this number by 0, it will give me the error here that it cannot divide by 0. So it can be useful. So another concept that I want to talk about is managing a state in the Gradio. So when you're building an interactive application with Gradio, you have to understand how to manage the states. The state here means the data that can change over time and needs to remember or access across different interactions or users. So in Gradio, we have 3 different states: the global, session, and browser states. The global state is shared across all users and all sessions. So it means that if one user makes a change, it becomes immediately visible to all other users interacting with the same Gradio application. So it is useful for shared resources like loaded machine learning models or configuration settings that can apply universally. Everything that you define out of the functions, the Gradio blocks, it is the global state. So it is really easy to be defined here. The next thing is session state. It is a data that is unique to a specific user's interaction session. So it is specific to the one user and one session. If you reload the session or close your web browser, that data will be cleared. So it is independent for each users and ensures that the actions do not affect the others. And this is ideal for specific information like chat histories in a chatbot or temporary calculations. You can define it with this command gr.state in the gr blocks. The last one is browser state. It is the data that's stored directly in users' web browsers and allowing values to persist across page reloads or even between different Gradio applications. So if you reload your browser, you close it and open it again, that data will be there and it will not be cleared for that specific users. So it is useful for some settings inputs or such as last entered text or selected theme by that specific users. And it can be defined by gr.browser state in the gr blocks. So let's look at the problem with the session state here. So as I mentioned, state is a data that have to be changed continuously in time. And another thing about Gradio is when you run your code in Gradio, it will run your Python code once, and it will design the UI that you want. And whenever you change some inputs, it will run just that specific part, and it will not run it from the top. So if you want your some data to be changed over time, you have to define it as a state. It is what I've done in this example. This example is, for example, I have a cart. I'm going to grocery shopping and I want to add some items or removing items in it. So the output of this code will be the whole number of inputs in my cart, and also showing me for each item how many is in there. So by creating the session state here, it helps me to build a dynamic and a stateful user interface where interactions update the underlying data and outputs in real time across the session. So I just have my blocks here. I defined my cart as a state. There is items that I want to add. I use the checkbox group because the users may want to choose more than one option here. I have two simple functions for adding the items and removing those. Also, I raised an error here that if the users want to remove an item which is not in the cart, it will give them that error that the item is not in the cart. I created two buttons, add and remove, and tells if they are clicked, I want these functions to be run. This is my input and output. The cart size is just a number, so I define it with your number, but for telling me how many of each item is in there, I have to define it with JSON. So with JSON, I have my item counters and telling my code that whenever the cart change, I want to give me the length of the cart and also the dictionary of everything items in that cart, and then launch it. So we want to look at this one. So for example, here I want to add water and orange juice. It will show that. I'm adding cereal to that. And maybe remove orange juice from the items. And then I want to remove the milk, which is not in my code here, in my cart here. So by removing it, it will gives me the error that the item is not in the cart. Get back to the code. Okay. As I mentioned that Gradio is supported on the Hugging Face. So on the Hugging Face space, you can Hugging Face can host your application and your codes, so you can use it for yourself or for others to share it. For using that, you have to go to the Hugging Face website, create your account, and specify the SSH key and also your API key in it. And then you can go to the Hugging Face spaces, create a new space, choose Gradio as your SDK for your project, and then it will give you the whole instruction for that. But I'm just for reviewing it, I just put it here. It gives you free options for the cloning the repository, but I recommend using the git clone here. After on your local computer, when you clone it, go to that specific directory, have your file, a Python file and requirement.txt ready, and put it on that directory. Just rename it as app.py because in some cases it doesn't understand this is a Python code you want to host. The name should be like this. And for the requirement.txt, you do not need to put a specific version of it. Just put the libraries you want that your code needed it. For example, Gradio, Torch, or Transformers. And Hugging Face will install that for you and take care of everything else. And then you have to commit codes to the git add for your application and requirement file, commit them and push them. And then Hugging Face will automatically build and deploy your Gradio applications. So here I am on my Hugging Face spaces. I have some space created, for example, here in greeting temperature. It's a simple code. It will ask for my name, ask me if it's morning or not, and the temperature for outside. When I submit that, it gives me the answer that is a good morning, it's 31 degrees today, and then convert it to the Fahrenheit. So it's real simple, but here it is hosted on the Hugging Face. If you want to see other codes or for your other spaces or for yourself, what codes they deployed, you can just click on the three dots here, go to the files, and here is my Python code. So it is a simple function, and I use the interface to build that. I asked to run discrete function, giving the input and also the output, and just launching it. So it's really easy to work with. But for creating new one, just click on your profile picture here, go to the new space, giving it a name, and maybe some description. Choose Gradio as your SDK. I want it blank. And you can choose the space hardware. So as you can see, except this the first one that gives me 2 virtual CPU with 16 gigabytes. Others are just you have to pay money. So I'm just using the free one, which is more than enough for my purpose. And I want my space to be public. I create it. And then on the next page, it gives you the instruction that I've just put it on this slide. You can cloning by the HTTPS, SSH, or CLI, but I recommend you to use the SSH. It's safer and it's better to work with. Create your Gradio application and just commit and push those. So this is how you can work it with the Hugging Face spaces. So this was the one I want to talk about Gradio. But I have 4 demos available to show you the how the ability of the Gradio. The first one is the flipping text and image. It's a simple code that you give it a text or image and it's reverse it for you. The next one is a BigGAN image generator that I'm using a model and I ask it to create an image for different kind of dog breeds for me. The third one is machine learning on Titanic datasets. So I have loaded datasets and do some cleaning for it, do some prediction. I didn't put much effort on the code, just the UI, so it is not perfect on that matter. And the last one is a chatbot. So I used a language model and create a chatbot with the Gradio. So let's take a look of my codes here. The things that I want to talk about here is in Gradio, you can have many tabs for your code. For example, here I have one tab for flipping text and the other tab for flipping the image. So within your GR blocks, you can just create gr.tab, put every code necessary to that tab and put it there. And then on the other tab, for example, in flip image, you have the codes that necessary for that specific tab you want. Another thing is sometimes you don't want all the settings or all the inputs be visible on your UI because it looks crowded. So you can create this GR accordion and put every settings, everything you want under, and it looks like better. And when you just click on this accordion, the setting will be visible for you. The code is just simple function for flipping the text and images, so nothing special about that. I'm just gonna run it. And okay. Here it is. So I just put my input. I just flip it and just flip the text for me. And it tells me that it has 26 character count. Here is the accordion that I talked about. If you want to just click it, I put it, nothing special here, but if you have more settings, do you want to share, you can just put it here to make it less crowded. And the other tab is for flipping images. As you can see, you can flip from your local computer, from your webcam, and also from the clipboard. So I'm just upload from my local computer the defaulted images, and here this is. So the next code was about the GAN creator. So I used the WordNet and some pre-trained models. Here I give the users two options to choose a breed, dog breeds from the list that I provided, or just type the breed name manually. And then I went converted tensors and then generating the image for itself. And there is nothing mentioned here. The other thing that I want to mention here is if you want to share this code with other researchers or anyone else, you can just put share is equal to true here, and when you run it, okay, besides the local URL it will give you, you have another public URL created for you, and it will expire in 1 week. So if you want to share those, you can just give this URL to others. So, for example, I'm using this one here, and this is my UI. So if I want to choose from the list, for example, I'm choosing Doberman breed here. With different random seed, you can get different images. The truncation is for managing the noise, and the scale factor is just how large you want your pictures to be. I'm gonna generate this one. And here is my picture. I can just use another random seed to get another image. And also, if I want to type the breeds manually, I have this placeholder to tell people what can they type here. For example, I want Samite. I got my picture, or another breed. And here it is. So this is how you can work with a big GAN on the Gradio. The next one was the machine learning code with the Titanic dataset. So I just loaded the dataset here, do some cleaning and labeling coding here, splitting the train and test, and do some accuracy and prediction on that test. So as I mentioned, Gradio supports plots. So and some charts. I have three charts here. Two of them is bar plot and one is heat map. The heat map is not supported on the Gradio, so I have to create it myself and just put it there as an image for the Gradio to display. And then, yeah, and if you, okay, for the image, for the bar plot is here. I have to just call the bar plot and giving it what I want to plot here, and my x-axis will be the sex of the passengers, y will be the mean of their survival. And I have another bar plot here also created. Yeah. Okay. So if I run this code, I have my model accuracy, and here's the plots that I wanted to be created. It's the survival rate by gender, the females and the males, survival rates by the class, the passengers, ticket class of the passengers, first class, second class, and third. And here is my heat map that I put it there as an image. So it's a correlation between different features in this data set. I have another tab for predicting the survival. So this is the input that you can use to predict if the passenger would survive or not. For example, if it's a female, 29 years old, no siblings, no parents, no one is abroad with her. And if the port is from Southampton that they arrived on, it predicts that they will not survive. But if I change the passenger class to the second class, you can see that they survived. But for the male passengers, they will not, except if they want to be on the first class passengers. So you can do some data analysis with the Gradio as well. So the last one is chatbot. So I created chatbot. I have my models from the Hugging Face. Here is the models that I've used. It is like any other LLM codes. You have tokenizer. You have to set up your models for it and do the prediction for the returns. And all you have to do for this one to be create the chat interface and chatbot for you is calling the chat interface class, giving the predict function you want, and launch it. So I've run it on the cluster. So I run it on the clusters and do all the forwarding things. Let's see if it's here. Yeah. Okay, here is my chatbot, and you can just talk to it and it will answer. Yeah. So, for example, their answers are reasonable, but I think it's the data is till 2021 or 2022, so it doesn't have any recent data. So you can ask it whatever you want and tested it. So it's a nice chatbot to work with. It may take some time to come up with the answers. Okay. So this was all about Gradio. Let's wrap it up. Let's compare it with other platforms. So the Gradio is really simple to use. As you can see, it is Python native and it has integration with the Hugging Face. The disadvantage is that it is less customizable. You don't have all the powers to customize the weather you want than web frameworks like Django, but it is really good for rapid prototyping, research demos, and teaching. The other option is Streamlit. It is data focused and state management. It can follow the data, but the cons, it's more verbose and less machine learning specific. But it is really good for data analytics, data operations, and dashboards. The last one is Django. It's how you have the full control. It is production ready, which is really great, but you it takes some time to learn how to work with Django, and you cannot just work with it just 1 day or 2 days of learning. But it is really great for production applications and custom workflow. Why and when we should choose the Gradio? So it is speed to deployment. If you can create and share machine learning demos in minutes, not days. It's focused on machine learning, not UI, so you can just put all your effort on machine learning, and just with some simple codes, you can have your UI designed. You don't need to know any front end, no CSS or JavaScript needed. Gradio supports JavaScript and CSS. They have some commands for it. You can look it up in their website. But as you see, I didn't use any, and I have my UI designed. So if you know these things, you can just use it and have better UI designed for you. Also, since it is integrated with Hugging Face, it has a great community there. You can ask your questions there. You can get some ideas about how designing your interface there. And all the codes for the demos is available on my GitHub account. Here is the link. So if you want to look at the codes, you can go there and try it yourself. And thank you for your all. And any questions?